Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at the chain rule under the topic differentiation. So before I begin, if you are not comfortable with the basics of differentiation, I would recommend you to watch my video on the basics of differentiation, because whatever that will be done in this video is a continuation of that. You need to know the basics really well in order to understand it. So without any other delay, let's begin. Right, so we are talking about the chain rule, that is CHAINRULE, chain rule. Now, what is a chain rule? The chain rule is a rule or a trick in differentiation when you want to differentiate a certain type of expression, and that expression is usually in the form of something like this. For example, let's say y equals to x plus 1 to the power of 2, and you want to differentiate this. Now, what one can do is you can go ahead and expand this. You can say, okay, x plus 1 and then x plus 1, then expand this. This gives you x squared plus 2x plus 1, and then now differentiate them separately. That's 2x plus 2. So you now say dy dx is 2. Yes, that is correct, but what if I now said, oh, the power was not 2, the power was 5? Would you go and do x plus 1 and then x plus 1 and x plus 1 again? I mean, it is correct, but it's very, very time consuming, and in an exam scenario, time is of the essence, so you cannot waste time. Now, the best way to go about differentiating these sorts of expressions, let's say we have x plus 1 to the power of 5, what you do is you take whatever inside the bracket, in this case x plus 1, and let it represent with a letter. Let me represent it with v. You can represent it with x, represent it with u, represent it with whatever you want. So if I'm saying x plus 1 is v, then that means my equation is now y equals to v to the power of 5. And we know from our basic differentiation rules, we know that dy dx would now simply be 5v to the power of 4, because you take one from the power and then you first you multiply it with the expression and then you take one away from the power. Now, this is one way of doing it. Me personally, I'm not really fond of it when you want to represent something like this. In this example, it's very easy, but when you get complicated questions, it does tend to get a bit confusing. So another way you can differentiate this, or it's the same way basically, but the other way you can remember it is simply by differentiating this as a whole. So don't really regard the x plus 1, just differentiate it as it is. So this becomes 5 into x plus 1, and then times it, times this one's power 4, and times the whole of the expression by the derivative of what's inside. So if I was to take x plus 1 by itself and get the dy dx of this, which is just 1, because if you differentiate x, you get 1. So I'm just simply going to times this by the expression again, times 1, and that would give me the same 5 into x plus 1 to the power of 4, which is the same over here. Now, if you are to go with this method, the one where you use v, then also you would have to eventually times it by the derivative of what's your v. In this case, our v was x plus 1, and the derivative of that is 1 itself, so the answer is still 5v to the power of 4. But mind you that when you are writing your final answer, do not write it in terms of v, because v is something, or whatever variable you're using, is something you made up to make the question easier for you. So make sure you write it back in the form that's correct. So that's 5 into x plus 1 to the power of 4. And the other way, of course, you can remember all of this is by differentiating it as normal, ignoring what's inside, differentiate to expression, and then times that expression by the derivative of what's inside. So that's a basic overview of the chain rule. It's not the hardest of topics, to be honest. If you practice it consistently, it's very easy and very easy to remember, and almost like free marks in any exam if they ask you to differentiate certain expressions like these. So let's look at the first example. First example I have says to me to find the derivative of y equals to x plus 2 to the power of 3. Okay, so I can go this by representing my x plus 2. Let me say that's v again. So I now have v to the power of 3, y equals to v to the power of 3. Finding my dy dx of this, that's dy dx is equal to 3v squared, and then I would have to times it by the derivative of what's inside. So inside it's x plus 2. If I try to find the dy dx of x plus 2, that's simply 1, because differentiating x would give you 1 and you cannot differentiate a constant term. So just times this by 1 again, and this will still give me 3v squared, but then write it in the correct form. That's 3 into x plus 2 to the power of 2. One thing you may have noticed by now is that whatever is inside the brackets in the question, in the original equation, is always also shown in the final answer. Next example we have says find the derivative of y is equal to the square root of x plus 6. Alright, so this may look a bit complicated at first, but let's make it very easy. We know that anything raised, or anything that has a square root, is simply that thing raised to power 1 over 2. So we can now write this as y equals to x plus 6 to the power of 1 over 2. So let's just go ahead and find the derivative of this. I'm not going to let this one be represented by v. Let me do this the other way. Just differentiate this as it is. So y equals to 1 over 2 into x plus 6 to the power of minus 1 over 2, because 1 over 2 minus 1 is minus 1 over 2, and times this by the derivative of inside. That's still 1, and then this is the same as y equals to 1 over 2 to x plus 6 to the power of minus 1 over 2. You can leave your answer like this, not a problem. If you want, you can simplify this further, but I don't think it's really necessary, because a lot of marks can be lost if you want to go ahead and simplify further, because eventually the examiners will be looking at the accuracy of your final answer. Right, so for the next example, it tells me to find the dy dx of y is equal to 2x plus 3 all raised to the power of 4. Right, so let's go ahead. Dy dx is equal to 4, because you obviously times this by 4, and there's a 1 over here, there's nothing, so 4 times 1 is 1. Suppose there was like a 3 there or a 4 there, we now do 4 times 4, which would be 16, or 4 times 3, which would be 12. 4 into 2x plus 3, all to the power of 3, because 4 minus 1 is 3, times 2. Why 2 on this occasion? Because if we take 2x plus 3 out and find the dy dx of this, this would be 2. And remember that once you're done differentiating this normally, you have to times it by derivative of inside, and in this case that's 2. And now all we do is we'll just multiply our 2 with what's outside. So our dy dx would now be 4 times 2, that's 8, into 2x plus 3 to the power of 3. And that's our answer for that example. On to the next one. This one tells me to find the derivative of y is equal to 3x plus 2 all raised to the power minus 1. Okay, good to know. So again, same way, dy dx is equal to minus 1, because minus 1 times what's in front, which is nothing, so that's basically 1, so minus 1 times 1 gives you minus 1 into, just draw that again, minus 1 into 3x plus 2 all raised to power minus 2, because you take away minus 1 from minus 1 and that gives you minus 2, and times this by 3, because the derivative of inside 3x plus 2 is 3. If you differentiate this will give you 3. And doing this, dy dx is equal to minus 3 into 3x plus 2 all raised to power minus 2. And that's the answer to that question. Again, if you notice it, whatever is inside your brackets from the question, in this case 3x plus 2, is always the same inside the brackets at the final answer as well. Right then, next example tells me to find the derivative of y is equal to x squared minus 1 all raised to the power 3 over 2. Okay, so this might get a little complicated. Now, my dy dx is equal to 3 over 2, because I times this by what's outside the brackets, which is 1. 3 over 2 into the same thing remains in the brackets, x squared minus 1 all to the power of 3 over 2 minus 1, which is 1 over 2, times the derivative of what's inside. So I have x squared minus 1 to be inside the brackets. Dy dx of x squared minus 1 is 2x. So I times this equation by 2x. Doing that, I have dy over dx equal to 6x over 2 into x squared minus 1 to the power of 1 over 2. Where did I get the 6x from? Because 3 times 2x, sorry, gives you 6x, and it's all over 2. So 6x over 2. You can cancel this out. 3. So this becomes dy over dx equals to 3x into x squared minus 1 to the power of 1 over 2. Quite simple, nothing much doing. Just make sure your basics of differentiation is correct, and also your manipulation of the original equation is spot on as well. Right, next example says find the derivative of y is equal to the root of x minus 1 all to the power of 4. Right, so this is a bit of a complicated question, but no worries. Let's rewrite this equation. Let's say our equation instead is y is equal to x to the power of 1 over 2 minus 1 to the power of 4, because we know that this is the same as x to the power of 1 over 2. So let's go ahead and differentiate this. Dy dx is equal to 4 into x to the power of 1 over 2 minus 1 to the power of 3. Now times this by the derivative of what's inside. So if I have x to the power of 1 over 2 minus 1, my dy dx of x to the power of 1 over 2 minus 1 would be 1 over 2x to the power of minus 1 over 2, because 1 over 2 times the 1 over here, so that would just be 1 over 2, and then you take away 1 from this power, that gives you minus 1 over 2, and differentiating minus 1 would give you 0. So times this by 1 over 2x to the power of minus 1 over 2. And doing this, we have dy dx to equal to 4 times 1 over 2 is 2, So this becomes 2, and then times that by x to the power of minus 1 over 2 becomes 2x to the power of minus 1 over 2 into x to the power of 1 over 2 minus 1 all raised to the power of 3. This can be taken as the correct answer, or you can simplify further if you want and say that dy over dx is equal to 2 over root x into x to the power of 1 over 2 minus 1 all raised to the power of 3, because x raised to the power minus 1 over 2 is the same as saying 2x raised to the power minus 1 over 2 is the same as saying 2 over x to the power 1 over 2, and x to the power 1 over 2 is the same as saying root x. So either of these two are the correct answer. Right then, and on to the final example for this video. It tells me to differentiate y is equal to brackets x squared plus 1 to the power of 1 over 2. And the question tells me to leave my answer in the simplest form possible. Alright, good to know. Let's go ahead and differentiate this. R dy dx, and by the way, they made it easier first by saying it to the power of 1 over 2. They could have just said y is equal to the root of x squared plus 1, but we know that is the same thing as what they gave us, so they simply made it easier for us. Dy dx is now equal to 1 over 2 into x squared plus 1 all to the power of minus 1 over 2 times the derivative of what's inside, and that in this case would be 2x. Again, the 1 over 2 came because I times it by what's in front over here. That's 1, so it stays 1 over 2. Take away 1 from 1 over 2 gives you minus 1 over 2, and the derivative of x squared plus 1 is 2x, because you times this by in front, so you have 2x. Take away 1 from the power, that's x to the power of 1, which is the same as 2x, so times it by 2x. Going at dy dx is equal to 1 over 2, okay, no, sorry, times this by 2x, so this is 1 over 2 times 2x, that's 2x over 2 into x squared plus 1 to the power of minus 1 over 2. Now the question said, if you recall, that we need to do it in our simplest form possible. So dy dx is equal to, this cancels this, we have x into x squared plus 1 to the power of minus 1 over 2. We know this is the same as saying that our dy dx is equal to x all over x squared plus 1 to the power of 1 over 2. Because it's a minus here, that means it was taken up, so if you want to take it back down as a denominator, you'll lose the minus and become positive again. And because it's the power of 1 over 2, we can now say that our dy over dx is nothing but x over the square root of x squared plus 1. And that is the answer for the final example. Again, you can note that from our question, x squared plus 1 inside the brackets, it's still the same thing at the final answer, just that it's probably changed positions a bit lower than it was at the beginning. So that brings us to the end of this video. Thank you for watching. Hopefully you enjoyed. Please do not forget to perform an LSS, that is like, share and subscribe. Thank you for watching. Have a nice one.